Hey, how's it going? So let's take a look here. Fruits into baskets, earliest finish time for land and water rides, trionic array. Alright, you're given two arrays of integers, fruits and baskets, each of length n, where fruits phi represents the quantity of the ith type of fruit, and baskets j represents the capacity of the jth basket. From left to right, place the fruits according to these rules. Each fruit must be placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit type. Each basket can only hold one type of fruit. If a fruit cannot be placed in any basket, it remains unplaced. Return the number of fruit types that remain unplaced after all possible allocations are made. So fruits 4, 2, 5, baskets 3, 5, 4. So fruits of 0 equals 4. Fruits of 0 equals 4 is placed in baskets 1 equals 5. What? Am I missing something? What is this? Is this a solution from earlier? I don't know why that appeared. Okay. Okay. Since one fruit type remains in place, we return 1. Oh, okay, this is simpler than I thought. So we want to place as many as we can. Each fruit must be placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit type. Okay, I've got it. And it's clearly brute forceable. If a fruit cannot be placed in any basket, it remains unplaced. Okay, well, and it's determined which one we can even put it in the first place. So, I don't know, there's probably a more efficient way to do this, but for f in fruits, so this is a quantity of fruits, and then we will have cnt equals 0, and then we will say for I in range length baskets. Pretty simple question. Okay, if baskets of I is lesser than or equal to f, then baskets of I equals 0, placed equals true, and break, I guess. Okay, so at the end of this, if not placed, then cnt plus equals 1. We weren't able to place it, return cnt. Cannot access local variable place where it's not associated with a value. Pretty sure I meant to initialize this defaults right here. I just forgot. Alright. These things happen. 0, 1. Interesting. Okay, so I guess we need some debugging stuff here. Print f I baskets I. Apparently it thinks that it's placing when it isn't, so oh, for hell's sake. Wow, I should retire. Alright. Okay, submit. Alright, sweet. Beats 88%, really? My n-squared algorithm beats 88%. Okay. Earliest finish time for land and water rides. You're given two categories of theme park attraction, land rides and water rides. Land start time I is the earliest time the ith land ride can be boarded. Land duration is how long the ith land ride lasts. The earliest time the jth water ride can be boarded, how long the jth ride lasts. Really? This is an easy question. Tourists must experience exactly one ride from each category in either order. A ride may be started at its opening time or any later moment. Or any later moment? Well, then it's not a start time. If a ride is started at time t, it finishes at time t plus duration. Immediately after finishing one ride, the tourist may board the other if it's already open, or wait until it opens. Return the earliest possible time at which the tourist can finish both rides. What? Okay. They're in order, right? I don't know. So land start time equals... Oh, each one has a different duration. Okay, that's kind of interesting. It's a little weird, but I guess it's interesting. Okay, so for I in range length, land start time. For J in range, water start time. You know what? This is kind of a land start time equals land start time I. Land duration equals land duration I. And then water start time equals water start time I. And then water duration equals water duration of I. Okay, so there's no reason to not do the first one that comes available first, right? I don't think that there is. What if we just did it both ways? I mean, we have the information here. This was bothering me. Okay. Let's do it both ways. So first time equals max water start time of land start time plus land duration. Okay, it's immediate, right? If it's not, we'll get an off by one and then we'll fix it. I'm pretty sure it's immediate. So first time equals whichever one comes later. And then end time candidate 1 equals first time plus water duration, right? And then first time 2 equals water start time plus water duration, land start time, and then ET2. ET2 is what? First time plus land duration, right? Water start time plus water duration. So we're starting that. Yeah. Yeah. And then best equals, I don't know, 10 to the very big number. All right, best equals min of ET2, ET1, and best, and then return best. All right, list indexed out of range. J. Don't need to repopulate that every time. All right. Output 11, expected 14. Now that's interesting. I must have missed something. Okay, so this is really dumb. What is the maximum water duration No. We started this. Let's finish this. So, water start time, water duration. Land start time, land duration. Right? Okay, something is wrong here. Print water start time, water duration, FT ET1. Yeah. Effed. God. This is pissing me off. Okay. Let's try this again. First off, land equals zip, land start time, comma, land duration. Pissing me off. Yes. Now, water equals zip, water start time, comma, water duration. Now let's not have any that start at the same time, because that's stupid. So we will say, well, that doesn't matter. It doesn't matter. Yeah. Okay. Right. And we're going to say for I, comma, j in zip. For I, comma, j in zip. And then this is going to be I, comma, j, comma, not 0, 1. And this is going to be I, comma, j, comma, 2. And I think that they should be sorted. Land.sort, water.sort, and then we are going to have cases. Cases equals, and it's going to be an end time and an end position, right? right, now we will never do a land if we've already done a land. We'll never do a water if we've already done a water. It just doesn't make any sense. Okay, so let's go through. We don't need this. I think we have to do 2 passes. We'll say for I comma j comma I don't know bit in land plus water like this, and then yeah, we're going to need the base case end time of 0, this case of 0. Then we're going to say for C in, we need to make a copy of it, cases like this, and then it's going to be end time comma completed bit. Yes. Now, if C, B, and B, then we've already done it, right? Then we're going to continue. Otherwise, if ET is greater than or equal to I, then in that case, cases dot append. There's going to be a new end time, and the new end time is going to be the current start time plus the duration, which is j. So it's going to be, so end time is greater than or is lesser than or equal to I. Then it's going to be max of I comma end time. Why does it have to be lesser than? It doesn't have to be lesser than. Max of ET comma I of CB or B, like that, right? So now it's going to be completed. And that should give us all of the cases. We'll say scene equals set of 0, 0. I feel like we should filter these out. New tuple equals yeah, like that. Then if new tuple not in scene, then scene dot add new tuple. Yeah, like that. Okay. Now, once again, best is going to be a really big number. So if CB or B equals 3 and max I plus J, yeah, and I don't know, new tuple 0 is lesser than best, then best equals new tuple 0. Return best. Let's see what it does. List out append takes exactly. Oh, right. I meant to replace that. Again, interesting. Okay, this is case 2. It's the same one that was failing before. 5, 3, 1, 10, right? 5 and 3 is 8, plus 10 is 18. Or you can do this one first. 10 plus 3. It is supposed to be the next one. Oh my God. Okay. The highest it can be is 4,000, right? The highest it can be is 4,000. So land dot sort and water dot sort. Yes. So I should not be struggling with this problem. This is kind of weird. So our bests for neither are 0. Our best for land is, and our best end time for water is 10 to the 12th, right? Okay. So we are going to say while land or water. All right. Now, if not water, then we're doing land. If not water or water of 0 is greater than land of 0, then we're doing land. Do land. Else so we know that water is true, or that water is bigger, right? For here. Okay. Assert water. It's either smaller or the other is not defined. I don't trust myself. I keep making mistakes. All right. Okay, so we are going to apply the land, best land, water, and both, right? Okay. And apparently you have to add 1 here, so let's walk through this here. Finish at time 1 plus water duration equals 11. Start at 11. Okay, there it's not adding 1. I don't know where I got that idea from. So we have land start and land duration, right? Equals land top 0, I guess. Okay, and then we are going to apply it to each of these. So best of 0 doesn't change. This one is going to be the 0. Best of 1 is going to be land, and this will be the min of best 1, comma, ls plus ld, right? And then this one we can't get to, but this one we can. So best 3 is going to be the min of best the min of best 3 and the max of best 2 plus the max of best 2, comma, land start plus land duration. So whatever the latest is, right? Damn. I am like aggressively bad at this. Water start, water duration equals water pop, and then this is going to be best 2. And this one will be best 1, and we will change this to water start and water duration. And then we simply want to return best 3. Eventually I'm going to get it right by accident. Cannot access local variable ls. Oh, I thought I fixed that. Water start, water duration. Actually, I take that back. I have no memory of having fixed that. All right. Oh, thank God. Oh my God. What are you doing? List index out of range. Use test case. Where's use test case? Okay, water start time. While land or water, right? Assert land. We did. So water is true, but land is not. Okay. Wow, I'm surprised that didn't cause an error in the original test cases. Okay, you're given an integer array nums of length n, and integer is, an array is trionic if there exist indices 0 is less than a p, is less than q, is lesser than n minus 1, such that nums 0 through p is strictly increasing, nums p q is strictly decreasing, and nums p through n is so up, down, up. Okay. Okay, yeah, that's fine. All right. I equals z equals 1. So increasing. Okay. Let's just find it. While I is less than nums and is less than length of nums plus 1 and what? Let's see, PQN equals -1, -1, -1, and nums of I plus 1 is greater than nums of I. Yeah. Then P equals I. No, we don't do that. I plus equals 1. Okay, now if nums of I plus 1 is greater, no, is exactly equal to nums of I. If I equals length of nums or nums I, then return false immediately. Yes. All right. Otherwise, it has to be decreasing. So strictly decreasing. Yep. Yeah. And it has to be less than n minus 1. So, yeah. So, if I is greater than or equal to lengths of num minus 1 or nums I. And then from here, we can just say for I in range I plus 1 to length nums. It has to be increasing again. So if nums of I is less than nums of I minus 1, then return false. Okay. And the pivot point has to be God, I hate you so much. You have no idea. All right. Okay, let's figure it. Let's fix it. All right. So direction equals 1. This means increasing. Increasing equals true. Change equals 0. All right, so yeah, so while length of nums is greater than 1, so it has to be at least 2. So is increasing equals nums of 1 is greater than nums of 0. If at any point in time nums of 1 equals nums of 0, then we immediately return false. If it is increasing, now, if is increasing equals is increasing, if increasing equals is increasing, then we're fine. If it doesn't, then we flip it. Increasing equals is increasing, and change plus equals 1. Then return change equals 2. Now, nums.pop0. You can time out anytime now. Expected false. Oh, right. Because the length has to be at least 1. Right. So the minimum length is 3. So if nums of 1 is lesser than or equal to nums of 0, or nums of -1, it has to be increasing again, is less than or equal to nums of -2, then return false. All right. Oh, man. That sucked. All right. Okay. See ya.